Action. Hello, we are going to present composite 3D printing of biomimetic human teeth. I'm Damani.
My name is Hang Nama.
I'm Vincent. Next slide. So basically, this article really hones in on compositing 3D printed biomimetic human teeth, and it basically explains the process of printing the biomimetic teeth through the use of different approaches, such as applying measured forces in order for it to be performed and evaluated and extracted, plus performing 3D printed type of teeth. Here are some methods that was being explained. So first, they did the specimen collection. So they grouped it in three different components. One, extracted teeth as a baseline, and also using the comparison of the teeth and natural teeth. And the second method was available type of known teeth commercially. Then using the 3D printing of the composite materials work in order for the type of teeth to be developed. Then using the X-ray microtomography, which means that the specimens will be like imaged using the TDI. The TDI basically stands for time delay integration. Then they will do the composite development, so using different materials to create composite materials, such as a ceramic materials. Then using digital lighting, so basically producing the composite after the composite are developed. Then use the force measurements, so basically conducting different experiments to measure the forces that's acting on the 3D printed composites, and then using data analysis in order to record the data based on the previous steps.
All right. Those are like horrible.
Yeah. All right,
All right. So here are the process to achieve the goals the Mani mentioned before. Um, haptic is the feeling, and tibutin is a model of the oral cavity. Our goal, again, to reiterate, is to achieve a model that's similar to a natural teeth. Right now, we're using PMMA, which is polymethyl microlate. The resin is honestly like perfect. It's cheap, it's affordable, same thing. It's it's strong, it lasts, and it's it's good with it's a biomaterial, so it's good with your living cells basically. Um, so so why do we need like a new material? So when we go to the dentist and they put in a new crown made of PMMA, usually, I mean, for me, it doesn't last long. Maybe I chew too much, but it starts to chip after maybe a couple of months. So our goal is, again, to find a material that could maybe replicate a natural feeling that's easier to cut into than PMMA, or yeah. Um, Filler. So we have filler. In addition, we have filler that we could put into PMMA that increases the impact strength a bit of like the model, but it also decreases the viscosity, which is used to when you form the shape of the teeth. So first we need to get a picture of what the teeth would look like. We're going to use XMT, which is X-ray micromography. These are not big X-rays, but they do an accurate job at scanning. And as you can see from A to B, they look pretty much all the same. C to D, the white spots show the filler inside, and um, show the white spots inside. And there are better methods such as CBCT, which is this big X-ray, but the images usually take a while to process and develop.
So in this slide, I want to talk about the results of the findings of the paper. And in this figure, they compare the mean cutting force between extracted enamel and dentine versus commercially available brands of artificial teeth. And in the figure, we can see that there's a huge discrepancy between extracted enamel and dentine versus commercially available artificial teeth. And It's one of the reasons why undergrad students really dislike working with and training on model teeth. So in this slide, this figure demonstrates the force required to cut 3D printed model teeth with different material composition. And it graphs the mean cutting force compared to the weight percentage of the reinforcement material. And we can see that as the reinforcement material increases, the mean cutting force of the model teeth decreases. And if we compare it to the results of the slides previously, compared to extracted enamel and dentine, we can see that some of these material compositions come really close in terms of required cutting force. So the paper discusses a correlation between mean cutting force and its versus material property ratio defined by h cubed divided by e squared, where h is the hardness of the material and it measures the material's resistance to permanent deformation, and e is the elastic modulus of the material and is the material's ability to resist deformation in the elastic area. And the paper discusses that we can use 3D printed materials with mechanical properties significantly different from natural enamel and dentine, but we can choose material that have similar H hardness divided by elastic modulus ratio, and this material will still give us similar tactile sensation or response when we cut it. And yeah, so basically we can achieve similar tactile response by carefully choosing specific materials who have specific values for this ratio. And yeah, so in conclusion, model teeth can be used for dental training, but commercially available model teeth requires much more force to cut than natural teeth. But the introduction of 3D printed teeth obtained from X-rays can give better visual and physical training to dentists.